Scientists at the University of Nottingham have managed to simulate the zero-gravity environment of space in a test tube, making experiments with weightlessness easier and cheaper. To carry out experiments in zero gravity, one normally has to take the expensive and complicated option of a trip into orbit. But now, scientists at the University of Nottingham have managed to simulate these conditions in their laboratory. There's a wide range of things where having a local zero gravity in a laboratory is very handy. Plant biologists want to develop plants for use in space exploration for food on long voyages. Others are interested in pure physics and in mineral separation. And by using reduced gravity, there's effective ways of separating minerals quite quickly and efficiently. Using magnets, the scientists can make some projects immune to the force of gravity. Other than space research, this has a practical application in things like mining and mineral separation. As rocks get rarer and rarer, mineral separation becomes extremely important. It's important now to extract rather small quantities from a background ore, and these techniques will give scientists access to those rare minerals. These techniques could show what plants can grow beyond the Earth's gravity. This is useful if humans want to thrive beyond this planet. A pair of spacewalking astronauts left the safe confines of the International Space Station and installed equipment for a new generation of cargo ships. They left the unmanned station in the hands of controllers in Houston and Moscow during their 4.5-hour spacewalk. Video pictures beamed in from space have become almost commonplace in the 21st century. This is a view of the International Space Station. The pair of astronauts floated outdoors on their third spacewalk in just over a month to carry out relatively mundane housekeeping chores. They had to replace scientific equipment to study galactic space rays and disconnect the electrical cable of a broken TV camera. Their most important task, though, was to install laser reflectors and antennas necessary for a new European cargo ship. The 6 old reflectors were built in the late 1990s and have been in orbit since 2000. These new ones will make it easier for the new automated transport vehicles, or ATVs, to dock. With only 2 crew aboard the space station, it had to be left unmanned during this 4.5-hour spacewalk. Flight controllers in Houston, Texas and Moscow kept watch over the vacated outpost. Live video coverage of the astronauts was kept to a minimum to preserve power for critical systems. Midway through the spacewalk, communication was lost when the main US radio link was accidentally turned off by flight controllers. They eventually activated the backup radio line, sending commands through Russian ground stations, then got the main system working again. The space station is billed as the largest and most complex international scientific project in history. It's a state-of-the-art laboratory complex in orbit, more than 4 times the size of Russia's Mir, and with almost 60 times the electrical power for experiments. Led by the United States, the International Space Station draws upon the scientific and technological resources of 16 nations: Canada, Japan, Russia, and 11 nations of the European Space Agency, as well as Brazil. It is hoped that research at the station's 6 laboratories will lead to discoveries in medicine, materials, and fundamental science that will benefit people all over the world. A huge sea of ice lies just under the surface of Mars, ready to be tapped by future explorers as a source of fuel and maybe even drinking water. Scientists also have discovered Mars may also harbour life, which might explain where some of the water went when the planet went from being a warm and wet place to the cold, dry desert it is now. Scientists studying Mars have been looking for water for a number of reasons. For one, life as we know it requires water. and anyone who wants to spend any time on the planet would need water to drink and to use as a source of hydrogen for fuel. Scientists are fascinated by what the finding means for understanding the weather and geology of Mars. It seems to have once had water on the surface, lots of it. There are deep canyons, one deeper and wider than anything on Earth. Places that look like dried up lakes or seabeds. The surface of Mars is now dry and dusty, and the ice that covers the poles is frozen carbon dioxide. With average surface temperatures of minus 53 degrees Celsius and a thin atmosphere, there is little hope of finding water at the surface. But NASA has a range of instruments to see if water is there, and if so, if it's easy to get at. Evidence has been seen in photographs of seeping water, and the orbiting Odyssey spacecraft was directed to look for chemical evidence of water, which could be recognizable because of its high hydrogen content. Hydrogen quickly combines with other elements, so if it is found on a cold planet, it is very likely to have teamed up with oxygen to form water. Scientists from across the United States joined up with Russian and French teams to analyze Odyssey's data. It will take much more work to confirm that the substance found on Mars really is frozen water. But at this stage, the experts seem convinced. As the Cassini spacecraft draws close to the planet Saturn after its 1 billion kilometre journey through space, the Science Museum in London has an exhibition explaining the UK science on board this and other robotic space missions exploring our solar system. British space science has come a long way since this giant rocket, now on display at the Science Museum, shot an early satellite into space in 1971. The museum's latest exhibition highlights missions planned or underway to planets and comets with British scientific involvement, including one designed to capture the so-called solar wind and bring particles of it back to Earth. Cassini completed a 7-year journey to Saturn and explored this ringed planet and its moons. Cassini was learning what scientists say will be some important lessons for us on Earth. Launched in September 2003, Smart 1 has used solar energy and its ion electric engine to reach its destination, the Moon's orbit. Smart 1 is a technology mission featuring new types of science instruments and new ways of spacecraft operations. Its success is a precursor for ESA's next-generation interplanetary missions. The European Space Agency's Smart 1 mission to the Moon is at a crucial and dangerous stage. Smart 1 is Europe's first mission to the Moon. And why go? After the Apollo missions over 30 years ago, the Moon has taken a much lower priority in space exploration. So why send a mission to it now? Well, scientists want to test their theory that the Moon is actually a piece of debris thrown out after another planet collided with Earth millions of years ago. Between 1969 and 1973, 6 Apollo missions collected 382 kilograms of material from its surface. Automatic Soviet lunar missions sampled 3 locations from 1970 to 1976. But all these samples were collected from areas close to the Moon's equator and on the side of the Moon visible to the Earth. The instruments on board Smart 1 will look at the Moon from an orbit and develop a global understanding of what is on its surface without having to land and collect samples. Just as important as the Moon mission is Smart 1's role in developing key technologies for future space exploration. The philosophy is small. It fits into a cube just 1 meter across and weighs less than 370 kilos. 6 people can carry it quite comfortably. Its propulsion is ensured by solar energy. Smart 1 is the first interplanetary spacecraft to rely entirely on solar energy to go into deep space. Smart 1 also carries a novel navigation system called O-band. O-band enables a spacecraft to calculate for itself exactly where it is in space. The question now is, can Smart 1 get from one place to another without having to be told by ground control? It's been over 30 years since a spacecraft visited Mercury, and NASA scientists are making final preparations for Messenger to blast off on a 4.9 billion-mile journey to the planet closest to the Sun. Messenger will take 7 years to reach Mercury's orbit, making 15 loops of the Sun on the way. Then it will spend 1 Earth year gathering data. Scientists hope the information will reveal more about the forces that shape planets like our own. On the only other visit to Mercury in 1974, Mariner 10 gathered data on less than half of Mercury's surface. There is still an entire hemisphere unknown to us. The information collected by Messenger will be invaluable to scientists. Messenger will make key measurements that will address the size and state of the core and at the origin of the magnetic field. By measuring Mercury's gravitational field and characteristics of its rotational state, scientists can determine the size of the core and whether the outer core is fluid. By mapping the magnetic field, scientists can distinguish among competing ideas for what is generating that field. To do its job, Messenger is equipped with 7 scientific instruments. An imaging system with wide and narrow-angle high-resolution cameras will provide the first-ever images of the entire planet. A bank of spectrometers will carry out chemical remote sensing using X-rays, gamma rays and neutrons and infrared radiation. There will be a magnetometer to map the magnetic field of the planet. A laser altimeter will measure the planet's topography. And 2 other instruments will study the atmosphere and magnetosphere. Mercury's proximity to the Sun has presented an unprecedented mission design challenge. The Sun is 10 times brighter than what we see on Earth, and surface temperatures at Mercury's equator can reach 450 degrees Celsius. Luckily, most of this spacecraft won't have to see those extremes because of an innovative design of sunshade to protect the body of the spacecraft. The Messenger project is the 7th in NASA's Discovery program of lower-cost, scientifically focused space missions. This is Titan, Saturn's largest moon. It's covered by an atmosphere so dense that no spacecraft or telescope has been able to see through it. Scientists say it's full of nitrogen and methane, which they believe is similar to that of Earth 4 billion years ago. When the Huygens probe travels to Titan, they will be waiting keenly for the results. Scientists hope they will shed light on the beginning of human life and our solar system. The Cassini spacecraft has travelled for 7 years to orbit around Saturn, with Huygens strapped to its side. The probe detaches and will coast for 21 days to Titan. As it hits the Moon's atmosphere and drops to the ground by parachute, scientific instruments aboard will begin collecting data. If they survive touchdown, they'll keep working on the surface. During its descent and after touchdown, Huygens will continuously radio data up to Cassini, which will in turn relay the information to Earth. The communication link between the probe and Cassini was developed by an Italian company, Alenia Spazio. It also developed Huygens' brain, the command and data management subsystem. This automatically manages the entire mission of the probe. It uses radio waves to penetrate the dense atmosphere of Titan. Scientists at NASA and Pasadena cheer after hearing the Cassini probe survived the first of 2 passes through Saturn's rings. The perilous 2.2 billion-mile journey took 7 years in what's described as the most capable space explorer ever built. As the probe approached Saturn, it pointed its dish-shaped antenna forward to protect it from dust during 2 passes through the rings. This allowed onboard cameras to take pictures. Scientists were unsure of what they would see. Cassini parked itself 12,000 miles above Saturn's rings for the next 40 years, orbiting the planet 76 times in that period. It's hoped the pictures beamed back will give scientists an insight into Saturn's structure. Scientists hope the pictures and data sent back from Cassini will show Saturn has a small rocky core, possibly surrounded by liquid metallic hydrogen. This, it is hoped, will unlock some of the secrets of the planet. At first, NASA scientists on the Genesis project feared the worst when the space agency's little capsule slammed into the Utah desert at some 200 miles per hour. After a 2.5-year mission into space gathering atomic particles from the solar wind, the capsule ended its journey, cracked open like a clamshell. The impact badly damaged an inner canister containing disks that collected samples. But scientists who peered inside the canister believed they could salvage some of the science collected by Genesis. They had feared the 350 palm-sized wafers that make up the disks would shatter like glass in the crash, and many of them did. But they were surprised to find some wafers fully intact, meaning the $264 million mission may not have been a total loss. Scientists found that the collector's disks inside the Genesis capsule were jammed together by the impact of the crash. The disks were so tightly packed that it took a full day to begin peeling them apart for inspection. Scientists say the wafers from the disks do not have to be fully intact to extract samples from their shattered pieces. Altogether, the capsule held billions of charged atoms from the solar wind. This could explain how the Sun was formed some 4.5 billion years ago. This is Navajo land, 25,000 miles of seemingly endless geologic art encompassing parts of Utah, Colorado, New Mexico, and Arizona. It's a nation within a nation, steeped in beauty and tradition. But more and more, the face of the Navajo landscape is changing. New development is being encouraged on the reservation, an area rich in natural and human resources. Many of the hogans that still dot the reservation were at one time the primary form of housing. Today, it's in these hogans that the tribal tradition of rug weaving is practiced and passed on from generation to generation. Using the dexterity developed through years of honing this craft, a group of women working in a Navajo collective are sewing the blue jumpsuits worn by NASA astronauts. Each suit requires 150 separate sewing functions, and nearly all met NASA's rigorous acceptance standards. It's a long way from the Navajo reservation to the shuttle simulators and training aircraft at NASA's Johnson Space Center in Houston. But it's the contrast that makes this relationship so intriguing. For the Navajos, the work marks another step on the road to economic self-sufficiency. Once joined to its twin solid rocket boosters and external fuel tank, the shuttle Endeavour began its trip to the launch pad atop a massive crawler transporter. At the end of the 4-mile and 6-hour ride, the spaceship was set a special voyage. Its mission: use this rocket motor to rescue a major international communications satellite, Intelsat 6. After leaving Earth behind in 1990, the satellite failed to separate from the second stage of its launch vehicle, preventing the firing of a rocket motor that would boost it to its intended position. Working anxiously from the ground, Intelsat controllers were able to free the spacecraft, saving it from a re-entry burnout, but had to leave it stranded in a uselessly slow orbit. The plan was to then have Endeavour's astronaut crew capture it with the shuttle's robotic arm and bring it into the payload bay. After attaching a replacement rocket motor, they released the satellite while they moved the orbiter a safe distance away. Intelsat mission controllers then sent commands to fire the booster and propelled it to the proper orbit. The two astronauts chosen by NASA to perform the repairs trained underwater at the Johnson Space Center in Houston. In addition to their work with the satellite, they were also training to work on the International Space Station, a project which was still on the drawing board at the time. The primary objective was to demonstrate their capability to perform extravehicular activities, or AVAs, over 3 consecutive days.